Alright guys, so let's go over manufacturing mode. Okay, so we got the simple part. We'll call it a bracket. And first thing you want to do to actually make the toolpaths for this is you want to go from design mode to manufacture. This is where you're gonna make your toolpaths. It's your CAM side. I used to call it Fusion 360 CAM, but now it's called manufacture. Okay, so once you're manufactured, I like to hit save. We have to set up the stock and the orientation. Okay, Fusion 360, it knows this is the model, but it doesn't know what we're actually doing in the model. I mean, you could 3D print it, you could laser cut it, water jet it, mill it. It doesn't know if it's on the lathe, which, I mean, it's not a round part, so it's not on the lathe. Not that you always have round parts on the lathe. Sometimes you have other shapes. Okay, so I'm going to go to this first icon as my setup. And once you're in setup mode, you need to select the orientation. Okay, so let's see. So the software doesn't know if we're milling or turning. Operation type, it's on milling already, but if we're on using the lathe, you put it on mill turn. Cutting, let's see, that's going to be your water jets and plasma cutters, and additive is 3D printing. Okay, so I got down milling. I'm going to select the orientation, okay, for my origin. I like to use this first one. I just think it's more handy. Sometimes it's more handy using the select Z-axis with the Y-axis. It really just depends on the shape of the part relative to the orientation. But most of the time for the parts that we do as machinists, the Z-axis plane and the X-axis is the way to go. Okay, so I selected that. Now I'm going to click on the Z-axis right here, and I'm going to click on the face of my part. Now the origin is in the correct position. It's not in the correct, it's in the correct orientation, but it's not in the correct position yet. I'm going to fix that in a minute. But let's look at this. So sometimes the orientation doesn't actually come up. Like you may have the blue arrow pointing up, which is your Z, which is correct, but you may have the green arrow, your Y-axis, going left to right. Okay, what you would do is basically select X-axis and click on like this edge right here. And if you notice, when I clicked on that edge, the X-axis is now going towards and away from us. If you want to deselect it, you can click this little exit, clear that out, and I'm going to click on it again, and I'm going to select this line, which it was already in the right orientation. So when I selected that line, what it did is it pointed the X direction the other way. Okay, save that. I want this X direction pointing to the right, which in all reality, what I could do is I could just turn my part, but say that you do want it pointing to the right. You would check this box right here, flip X-axis, and it flips it. Okay, origin, you can do stock point, and when you click the box point, what you'll notice is it gives you different options of where you can select the origin at. Okay, now that's assuming that you want it on the stock. Okay, you also do your model box point, which when I clicked that, what it did is it moved the points to the model instead to the stock, to the stock corners. Alright, so I'm just going to click, actually let's put it let's put it up here. It doesn't really matter. You just want to put the origin, your X and Y Z0, somewhere where it's just useful. Okay, you want to put somewhere where you may have some kind of repeatability issues, or you actually may have trouble setting the X and Y. Like on a round part, you use the indicator to dial everything in and set your X and Y. So you wouldn't put, on a round part, you wouldn't put it on the edge. You'd put it in the middle of the part. Okay, and rectangular parts, you put it usually in the corner somewhere. Okay. Sometimes if you have something that the part's symmetrical, like it has many features that are symmetrical, you may want to put the origin actually in the middle, something like that. And I know in Garrett's class, I think he puts the origin in the middle of the part, so it'd be something like that. And I like to put it in front view and make sure the origin is actually on the model instead of the face. But it just depends on your how you're gonna set it up. You may want your Z0 on the face of the stock of the part instead of the model itself. And in that case, I would go to stock box point, and I would keep it on the stock. Okay, so you would face down. So you would set your tools on the stock and actually face down to the model, but your Z0 would be on top of the stock. For G-code editing purposes, and just being able to look at the G-code on the machine, I like to keep it simple. I like to keep my Z0 on the actual finished face of the part. So I'm gonna put this back on model box point, and I'm gonna put my origin up here in this corner. Okay, a lot of people like to keep the origin to the left, like the closest point to the left. The pros of doing that is all of your G-code X and Y values are in the positive. So if you have to do any kind of editing, everything's in the positive values. You're moving over X 1 inch and Y 1.25. Okay, now with it being in the corner up here, I would actually have to subtract down. Okay, because my Y0 is up here, so when I come down, I would come down 1 inch or 1.25. So be Y minus 1, Y minus 1.25, whatever that distance is. But the pros of having it up here is the way that vices are made. Your fixed vice jaw is the most repeatable surface on the vise. Okay, you got two gripping points. You have your moving jaw that you lock and unlock your part, and then you have your fixed jaw. Okay, for repeatability purposes, it's better to have your Y0 up there, but to keep the G code simpler, it's better to have the point right here. So it's really just preference. Depends on what you're doing. Okay, so I got my orientation and position of my X and Y Z0. Then I'm going to go to my stock. And it really just depends on what you're doing right here. On this part, what I'm going to do is I'm going to make my top offset at 0. And what changed, I don't know if you actually saw what changed, but it was at 0.04, right? So that means I have something to face off right there. This part I'm actually not facing. We're going to say our stocking material is already to the width. Okay, and we just gotta cut it to length. So in that case, I'm gonna have my stock right there, and a lot of times I just set my stock at 0, 0, 0. Okay, That's because when I actually set up the toolpaths, I know how many passes to take, and I actually like to get the correct number of passes within the toolpath itself. So a lot of it's just preference. Okay, sometimes certain methods are easier than others. You really just want to go the route of getting the part. You know, what's the easiest way to do it that gives you the correct toolpath that you need. Okay, and sometimes if you're not getting the correct toolpath or the desired toolpath that you want, you go a different route. Right? But there's no, I can't really say there's any right or wrong way. Now, I mean, there is proper machining. Sometimes, you know, you're machining, you know, a more professional way. Okay, so I'm gonna hit OK. There's one more tab right here, your post processor. You can put your program name and number. Program comment. That's the actual name. So I would put first assignment. If I wanted to be program 000500, I'll just type in 500 right there. And this machines WCS, you could change different work offsets. We're going to leave it default, so it comes up as work offset G54. Alright, so I'm going to hit OK. Since I get that set up, I'm going to hit save. And I like to name my setups by operations. So we'll call this operation 1. Okay, so let's see. This part right here, let's measure it. So it's 2.5 inches by 6 inches. And the holes are 4 inches apart, and they start off from one edge, from this edge right here. Let's see. Now this is just an example of how I use the CAM software. It really depends on what vise you're using. The width of your vise, you may or may not be able to cut each one of these sides, this side, then this side, without cutting into the vise. Your typical vise width, jaw width, is 6 inches, and this part is 6 inches. So you would kind of be skimming up against the jaws of the vise. So keep that in mind. But we're going to say that we're using a vise that's a little bit smaller. Okay. So what we're going to do is we're going to go ahead and we're going to cut this side and then this side. Okay. So I have a few different toolpaths to pick from. For something like this, 2D contour is the way to go. So I'm going to select 2D contour. And the first thing I'm going to do is select the tool. And you could create a toolpath. You can create a tool, or you can use one that's kind of the default system. Let's look at our sample tools. Okay, so we have a few different tools. Let's use one of the filters. So I'm going to do milling, and I'm going to use a 1/2 inch mill. These are the options I have. Okay. We'll use this flat end mill right here. And I'm going to view the tool. I'm going to check the tool number. Number 0. Interesting. Alright, so I'm going to go ahead and select that. Oh wow, this is new right here. Okay, so the preset. I don't know if this is because I selected a default tool that they had in their library. Usually I make a tool. But we're going to say we're cutting aluminum. And we'll just say we're finishing. Now it's already got the speeds and feeds in here. I'm going to leave it at that, what it has. Alright, so first thing I'm gonna do is I'm gonna select a contour, that the edge I'm actually gonna cut. So I'm gonna click on right here where it says contour selection. Then I'm gonna hover over to the edge of my part. Now notice when I get to the edge, see how it highlights the whole perimeter? I want to select just this line right here, right? So what I'm gonna do is I'm gonna hold my Alt key down, and I'm gonna select that edge, okay? And it doesn't matter if you select the top one or bottom one. A lot of the CAM software it does. In this case, it doesn't. So I selected that. I'm gonna leave everything default right here. I'm gonna go to my next task, my heights, and what I'm gonna do is on my bottom height, I'm gonna put it on model bottom. Okay. Sometimes you'll want to go a little bit further because the radius on the end mill. So in that case, I can go extra 50 thousandths deeper. Passes. I'm just gonna take one pass. And if I hit OK as is, what you'll see is a toolpath like this. Alright, so I'm going to right click here. If I simulate it, the tool holder kind of covers up the view of the tool, right? So I'm going to put this on transparent, and I'm going to hit play. Alright. Now if I click anywhere on my screen after I simulate it and drag to the left, I can kind of do a rewind. Right here is what I don't like, okay? When the tool actually engages the material, it engages right on the tip, okay? You may or may not have a burr right there. So I actually want to start a little bit above the part, okay? So I have different ways of doing this. Probably in this case, the best way to go about it is actually use this tangible fragment extension. Now I could change the lead in or lead out. I'm just gonna go to extra 50 thousandths right here. Alright, when I simulate it. Alright, so if I rewind and come up, when it starts engaging the material, it's kind of still engaging. It's coming in a little bit above the part now. Okay, we'll call that good. Another thing to do is check. I like to put it in front view to actually make sure it's going deep enough. Okay, it looks good, so I'm going to close that out. I'm going to name this side cut. Alright, now save that. I could create another toolpath and do the other side, so I could right click on this and duplicate it and then make one left or right and change the geometry that is cutting of which side. I'm going to undo that. In this case, what I'm going to do is I'm actually going to go to my geometry, to my original cut, and I'm going to click also this edge, okay? Now remember, hold your Alt key down and then click on it. You can select individual lines. Alright, so I'm going to hit OK, and I'll do both of them. Now this yellow line going across, that's a rapid move, okay? So it's going to come in, cut, it's going to lift up for clearance, it's going to wrap it in position, come down, and lead in with a radius. Okay, so I got my side cut. Now the drilling. Before we select the tool, let's go ahead and measure this. So it's a 1-inch diameter. So we need to drill it for 1 inch, okay? So I'm gonna go to drilling. And I'm going to select a center drill first. So I'm going to center drill. I'm going to edit this tool. Let's make this tool number 2. I'm going to hit accept. On my geometry, because I'm using selected faces, I'm going to zoom in, click on the wall of that hole, and click on this wall. Heights. Now, if you look at how deep the hole's going, it's going to the bottom of the hole by default, right? Center drilling. Let's see, what I'm going to do is I'm going to change this to absolute on my bottom height, and I'm going to make that minus 0.03. Okay, now when I do that, you can see it's just drilling 30 thousandths deep. Okay, that's on absolute, and I'm going to hit OK. Now notice I skipped a bunch of stuff. Okay, it doesn't really matter. A lot of the default settings will work fine. You usually want to keep your programs as simple as possible. And the default set, if you go in and change everything, you don't know what you're doing, you're usually going to screw some stuff up, which is a good thing. Sometimes you need to do that a few times and kind of explore, what's in there and how it works. But a lot of the default settings, you can get by with just changing just a few things and get the desired toolpath. So I'm going to click here. I'm going to name that center drill. How's that noise? Okay, so I get the center drill. Now I'm going to go in, I'm going to drill it. So I'm going to click drill, and I'm going to select the drill. I already have a 1-inch drill here. If not, I can make one, or I can edit a drill that's already in the library. You just right click on it and go to edit tool and change the diameter and name. So I'm going to select 1-inch drill, and I'm going to go to my geometry, and I'm going to go ahead and click this face and this face. Okay, and I put it on front view. It's not, the tip's going to the bottom of the hole, but the actual drill body diameter isn't, right? So I would change on my heights tab. So all of the clearance height, retract height, feed height, and top height, we're going to leave at default. And we're going to keep it on the whole bottom. But if I select drill tip through bottom, what it'll do is it makes the body actually go to the bottom of the hole. Okay, and I like to go a little bit extra to eliminate any kind of chance of a burr. So if I type in 0.03, it'll go 30 thousandths deeper. And say if I want to peck this, do a peck drilling cycle. By default, you just have drilling there, rapids out of the hole. If I want to peck, I have chip breaking and deep drill, full retract. In this case, I'm going to use my chip breaking. Okay, and I'm going to usually the default settings it has right here works great. I've never had any problems with these, so I just leave that as is, and they calculate that out pretty good. That works pretty well. So I'm just going to hit OK, and I have something like that, right? And I'm going to name this drill 1-inch. It doesn't really matter what you name it. Just name it something that, say you have a coworker, he sits down and he can look at it and know what's what. Okay, or if you come back a year later, you can look at your names and operations and kind of tell what's going on. Okay. It's just a better way to organize it. Plus, it puts notes in the G code, so the operator knows what's what in the G code. It isn't just like a long list of G code. Okay. Actually, it has some kind of categories or whatever. All right, so I got my drill. I could also cut this out. I'd want to use a smaller drill. We're going to use a 1/4 inch. And keep in mind, because we're using a round cutter, you're not going to get the corner. You're not going to have a square corner there unless you turn your part up and cut across. You could get a square corner. But in the current orientation, you're going to have a radius right here. Okay, and most engineers and customers are aware of that. I would check if the print doesn't specify. I would still call and check, because sometimes they're assuming that you may create that some other method. Okay, so if I wanted to cut this out, I could use 2D contour. I could also use 2D pocket. Now, pockets are typically closed features. Over the last few years, open pockets have become more and more of a thing. Now, if I hover over this edge, it wants to select the whole outer perimeter, right? So I'm going to use my Alt key, hold it down. I'm going to click here, here, and here. Okay. I'm going to be honest, I haven't used the open pocket in a while since the last Fusion 360 update, so they might have changed some stuff. Alright, so tool. So I select my geometry. Because I opened up 2D Pocket and just clicked some edges of the model, it automatically switched over to geometry and selected that geometry. But I still had to select the tool. 1-inch end mill isn't going to be good because it's going to have a really big radius right here. I want to minimize the radius, so I'm going to use a 1/4 inch end mill. And let's see, let's look at the sample tools they have here. I don't usually use the sample tools. Alright, let's put this on milling. They've just recently came up with this new tool library right here. It used to be completely different, so bear with me. I actually don't know everything about the new tool library, unfortunately. So I'm gonna put this. You want to treat these as filters right here. Well, it says filter right here, so they're filters. So when I click here, it's gonna filter out all the tools except flat end mills, right? It doesn't have a 1/4 inch end mill. Oh yeah, it does. There we go. 1/4 inch. Let's see if we can edit it. Now usually you can right click here and edit the tool. So what I want to do is change the tool number. But let's let's try it out. See, it doesn't actually let me change the tool number. It's weird. We'll try it a different way. Okay, so I'm going to go ahead and select that. And I'm going to leave the speeds and feeds here. That gives me, I'm assuming they're going to be okay. Depending on the type of machine you're using, you may or may not be able to go 12,000 RPM. If you're using a VF1, I think the VF1 is 8,000 RPM maximum. So you'd want to lower your RPM. Actually, let's just do that. Let's make the RPM 7,000. I like to keep my ramp spindle speed and my regular spindle speed the same, because if not, it'll sit there and change every time the type of movement changes, which is kind of annoying. Cutting feed, right? You know what? I said leave those, the default settings on your speeds and feeds. 99 inches a minute. It really depends on how deep you're going and how much material you're cutting out. I'm actually going to jump this down to 40. Now, On a bigger end mill, you'd want to go a lot faster. Lead in, I like to make my lead in the same as my typical feed. Ramp, I usually like to go a little bit slower on ramp. Okay, so I have my geometry selected, my tool selected. Now, if I just hit OK as is, it doesn't really know how deep to go, right? So I'm gonna do is I'm gonna put this on model bottom, and we'll go a little bit extra. All right, that's to compensate for any kind of radius on the end mill. All right, so let's just hit OK as is and look at the toolpath it gives us. All right, so look at what it did. It cut that whole bottom. Okay, why did it do that? Probably the geometry I selected. There's probably something going on there. Let's. No. Okay, so usually it doesn't do that. Crazy. Okay, one thing about Fusion 360 is they're always doing updates. So sometimes you go use the software and it'll work just completely different. They did a new update and they're trying something else out. Okay. They make a lot of changes. Sometimes big changes, sometimes little minor changes. And you go use software, the software, and you won't even know they updated. You'll go click on a button, and that button's not there anymore, okay? Or they renamed it, or put it in a different location, or change the process, okay? Sometimes they'll make some changes, and then they'll change it back. I think they do some kind of user experience test to see how the users actually like it. Now, I used 2D Pocket, but the toolpath it gave me was more similar to something like an adaptive clearing. Well, no, I can't say that. I don't do open pockets too often. But I do make open pockets. They don't usually work like this. Okay, so in this case, we're gonna go a different way. We're gonna use a different method. We're just gonna use 2D contour. A lot of these functions, or a lot of different features on the model, you could use. There's more than one way to do it. Okay, sometimes you can do 2D pocket, sometimes 2D contour. Okay, so I'm gonna go back and select that tool. I'm gonna have to find my 3/16 end mill again. I usually just put in basic speeds and feeds and dial it in on the machine. It's the easiest way to go about it. Usually, I have some kind of basic go-to feed rate values for everything, and when you actually go to run the part, you play with the overrides. You speed it up and slow down. You see how the tool performs, and you observe it and listen to it and see, check out the shavings and surface finish, and you just keep bumping the feed rate up until you get the machine running as fast as possible, but the same tool life and quality surface finish. So, and then what you do is you edit the speeds and feeds and just change them and make that your speeds and feeds. Let's see, I have 50. Okay, so same thing. I'm gonna hold my Alt key down. I'm gonna select each one of these lines. On my depth, I'm gonna put model bottom. and we're going to make it go a little bit extra deeper, 30 thousandths. If I just hit OK as is, I'm going to get a toolpath that looks like this. Okay. Now, the problem with that right there is, for one, I'm using a 3/16 end mill, and that's going to be my chances of breaking a tool are going to go up, because it's just going to plunge down there and cut all that material at full depth. So you may want to do is on your passes tab, for one thing, I'm going to change my tangible fragment extension, and let's see, let's go 100 thousandths. Basically, when it comes down, that's going to do, it's going to change the distance from here to here, okay, on the lead in and lead out. Okay, now it's not the lead in and lead out. My lead in and lead out is this green area right here. But right after it leads in, basically I have an extra 100 thousandths before it actually engages the material. Alright, so I'm going to go back here and right click and go to edit. And I'm going to go to passes. So my stock material is a 1/2 inch thick. So what I'm going to do is I'm going to go multiple depths at 0.125. And hold on, my alarm clock keeps going off. Okay, so I'm gonna go 1/8 inch deep. Okay, so I have multiple depths right here. Alright, so it's going to take a few passes. So that'll take some of the load off the tool. If I right click on 2D contour, go to simulate, and hit play, that's what it's going to look like. Okay, now if we actually show the stock here, you're going to have something that looks like this. Okay. Now the problem with that is when this, we'll call it the island, but when this material actually gets cut off from the stock completely, and it gets free, it's got to go somewhere. It can either fall down or get spit out from this side. But what you're probably going to run into is, this is just a 3/16 end mill, so it may get pinched in between the stock material and the tool, and in that case it could break your tool. Okay, if not break your tool, it's going to leave a mark on the material, on the part. Okay, so we don't really want that, because your quality, the part wouldn't look good. It'd have a little nick in it. You don't want that. Let's make sure that we hit save. Okay, so I'm going to right click on this, go to edit, and on passes, I'm also going to select this roughing passes, okay? And I'm going to give it a number of step overs. Let's say, let's put it on 3. Alright, so what that's going to do is actually going to feed in there 3 times, okay? And I just put 3 because I'm only using a 3/16 end mill. So a 3/16 end mill, the diameter is 0.1875, okay? This distance is 1 inch. So I'm thinking, my mindset is thinking, you know, let's reduce the amount of material that would be left from the stock. So when it breaks free from the stock material, there's not much there to get pinched, if anything at all. Alright, so let's simulate this. So it's going to look something like this. And as you can see, I have a radius on this corner right here. Okay, that's because my end mill is round, gonna have a radius there. Alright, let's speed this up. Looks good. And there's our toolpath, okay? That's just the very basics of using the cam, okay? There's more to it. There's a lot more to it, but that's how I use the software. It's like the bare minimum, like simple program. Okay, so you have different toolpaths, but your main toolpath is, 2D contour, drill, and 2D pocket. I could also do a 2D pocket on these holes if I wanted to instead of drill, and it would look something like this. Let's see, on the bottom. I'm just gonna hit OK as is. And basically, what it would do is cut out the material like this. Notice how it's ramping in. My default settings for pocket is a helical ramp in. And same thing as 2D contour, I can add more passes or depth of cut. You can save or leave stock. Usually, typically on 2D pocket, what you'll do, depending on what the print specification is and type of material, what a lot of people do is they'll leave stock material and they'll come in and remove the material and then do a 2D contour to do a finish pass. In this case, I'm not going to do that. So I can add more depths of cut or incremental depths. And I'm going to simulate. I can speed and slow down my simulation. And it's a good idea to make sure your tool is actually long enough to cut through. Now, you would do that on the machine. Doing that in the software isn't as important on basic 3-axis milling. When you get to 5-axis milling, yeah, clearance is huge. Okay, so if I want to actually turn this into G-code, well, first thing let's do is save. So I hit save. If I want to turn this G-code, I can post-process just that 2D pocket. Now, when I do that, I'm just going to save it anywhere for now. When I do that, it's only doing that 2D pocket. Okay, that's the only G-code it gave me. So that's not really what I want. So what I want to do is basically post-process all of the toolpaths I just told you to. Okay, all the processes. So I'm gonna click on the operation, then right-click, and go to post-process, and now it's gonna post all the processes that I just assigned to that model. Okay, so program name 500. This is gonna be the name. This is gonna be the program number. Now, you want to make sure you have the right kind of machine. So milling, by default, it selected the previous machine that I usually use. So your settings may not be set up yet, or not really set up, but you may have not posted any code yet. So there may be nothing right there, or some kind of default machine. So I'm going to select milling. Vendors, I'm using a Haas mill, so I'm going to go down to Haas automation. And now when I have milling and Haas set up, selected, it gives me 3 different options. Okay, for milling, I just use this pre-NGC. For lathe, I just use the Haas term, but this pre-NGC works pretty good. You also have your A-axis, and I haven't used the UMC yet, so I don't even know how that works. But the pre-NGC works pretty good. You could change the parameters of how it spits out the code. Sometimes they'll use high feed rate instead of actual rapid moves. I like to have it on G00, so when I put my overrides on, that I don't like crash into the part on a setup or anything. Okay. Preload tool, no. Not on the mill I'm using. But I like to keep this on G00 right here. And I like to use G28 instead of G53. It doesn't really matter really on that. I mean, actually I've been using G53 lately, but it's different home moves. Well, not really home, but you can also move up and out of the way for G53. But I would definitely use G00. If you're new to programming, use the G00. The reason why, if you use high feed rate, it'll put in 500 inches per minute, okay? Now, typical setup process, you're setting up a machine and you're running a program for the first time. You want to slow down your rapids to make sure everything's right. You don't come in and break a tool or crash into the part. Now, you can't do that if you're using high feed rates, because you would have to override your feed rate, which would be annoying because you'd constantly be jumping back and forth from 100% to slowing down your feed rate for each move. You know, if it's moving out for a clearance and using a high feed rate, if it's coming in and engaging the material, you know, you don't want to be jumping back and forth on your overrides. It's just a lot easier using G00. So let me hit post process. I'm gonna save it. I'll just save it wherever. Alright, this is my G code. And you take this G code, kind of view it, make sure everything looks good, and save it to USB or to the machine. But let me know if y'all have any questions, guys.